Okay, today what we're going to be looking at again is something that a formula that you studied in grade 11. So even though it's kind of a review, I put up a goal here for us. So I will use the present value formula to calculate the principal that needs to be invested. So as I said, this is a review of 3C and you studied the present value in grade 11. So first of all, the present value is the amount that needs to be invested now. Okay, so that's why it's present value, to have a future value. So in other words, I want to know the principal that I need to invest. So I'm just going to quickly look at how the formula was developed from the original compound interest formula. Okay, so this is our starting place, okay, and you can see that I want to get down to where these stars are, this other formula. So the first thing that we're going to do is I'm interested in the principal, the principal. So here's the principal here. So I want to rearrange this formula so that I have it that it says P equals. Now, in a previous unit, we've talked about rearranging formulas. So why is P not by itself? Well, because it's being multiplied by this bracket. So the opposite of multiplying by something is to divide both sides by the 1 plus I to the n. So if I divide that side by 1 plus I to the n, what happens is it actually divides out and I end up with p by itself. Now remember, whatever I do to the one side, obviously I have to do to the other side, and so I end up with this. Now, what we end up with is A divided by 1 plus I to the n equals P. And in fact, these two formulas are identical mathematically. The only difference is you can see is when it's rearranged in this way, we say PV, present value, but it's exactly the same. So you're finding the principal that you need to invest now so that you can get this future A amount. So that's where the formula is developed from. So let's take a look at the formula and answer some questions. So first it says how much money needs to be invested. So as soon as I see how much money needs to be invested, it's telling me something about I need to invest something. So that's going to be my principal. Okay, and in this case, it's going to be PV. And it's per year compounded semi-annually for 18 months in order to have. So I want to have this in the future. So as soon as I know that I want something in the future, I'm going to start with my present value formula. And the same way as all the other formulas, we're just going to write down our variables on the right-hand side just so that we can get it from the question. So if we look at our formula, one of the variables we need to know is A. Another one we need to know is the I. And the last one I need to know is the N. Now, if we look at A is the future amount that I want. And so that's that $5,500. My interest rate per compounding period. So I have 10% and I'm compounding semi-annually. And if you remember, that is about 2 times in 1 year. And because that number is easy enough for me to work with, I'm just going to divide it by 2. And then I have my N. My N is 18 months semi-annually. Now, before I actually put that down, let's take a think about that for a second. If I had put 18 and divide it by 2, because semi-annually, that would tell me that they're going to pay me interest, 9 times. Now, is that really what's going to happen here? Are they really going to be paying me interest 9 times? Well, I don't think so, because semi-annually means every 6 months they're going to give me interest. Okay, so this just isn't going to work. So I'm going to have to think every 6 months. So how many 6 months are there in 18? So in a sense, I could go 18 and divide by 6 because they're talking 18 months, and semi-annually is every 6 months, and you can see that that's actually a 3. So if I use 9, I would be off quite a bit because they're only going to pay me interest 3 times. So taking all this information and substituting it all into our formula, so we have the 5,500 and we have 1 plus the 0.05, and it is to the power of 3. And taking our calculator, we end up with $4,751.11. Notice that number is much smaller than the A, and it should be because we're making interest. Okay, so therefore, I would need, oops, sorry about that. And again, we're talking about money. Make sure you put a dollar sign. $4,751.11. Okay. All right, let's move on to the next question. Now, the next question is we have Amanda, and Amanda needs $9,000 in 3 years' time. Okay, so she needs that in the future. So that tells me I'm looking at future numbers here in 3 years' time. She can invest the money at 4% per annum, that means per year, compounded quarterly. How much should she invest? So just like the previous question, I can see I need to use this formula, the present value formula. So I'm just going to bring another one down here for us. And just like the previous questions that we've done all along, is we're going to put our variables along the right-hand side just to make life easy for us. Okay, so this time what we want for A, I, and N. Well, our amount this time is $9,000. Our interest rate is 4%, and it's compounded quarterly. So that means we need to divide it by 4. And again, a fairly easy numbers. I think we can calculate that in our head even. And N, how many times they're going to pay us interest? Well, I'm doing it 3 times for 3 years, and they're going to pay me 4 times every year. So my N here is 12. So there was really no trick in here with this one. So again, it's just a matter of taking that information that we have on the right-hand side and substituting it into our formula. And that I do not like. I keep hitting one wrong button on my pen many times. Okay, to the power of 12, and we end up with $7,987. And what's your rounding decimal 404? Okay, now with this one, you can see that we're talking about a fair amount of money that we want in the future. So we have to invest a little under $8,000 to make that happen. So all we're going to do now is we're just going to put a therefore statement, and I'm going to type it for us. She needs to invest money signs $7,987.04. Okay, so now you can have some lovely mathematical pleasure time yourself. Have fun.